Okay, so continuing, no? So we will now go to this last stretch of our video, no? So we have 21 slides left, and we are now on slide 13, no? So still on electric charge, no? So when we charge an object, we are actually transferring electrons, no? So a negative charge particle, no? So that's how we think of our electrons, no? A negatively charged particle. So again, no? Our our uh, our atom, no? So the atoms that we have, guys, no? They So the atoms that we have, no? So we have, no? One is protons, and usually protons and electrons, no, are equal in number, no? So aside sa protons and electrons, there's also the neutron, no? Now the atomic number, no? The atomic number is actually no dependent on the number of protons, no? So the protons dictate no the atomic number, while the atomic weight, or sometimes they call it atomic mass, no, because the effect of gravity is not that significant anymore when it is so small, no, that the atomic weight and the atomic mass are sometimes interchanged, no? So how do they get the atomic weight? Again, the atomic weight is the number of protons, no, and then plus the number of electrons. So when you combine them together, they constitute what we call the atomic weight, no? So again, no, electrons are what? Negative charges. Protons are positive charges, but the electrons are the ones that move from one material to another, no? Now the object that gains electron becomes negatively charged, no? So kung ang gindugangan sang electron, that's the material that we eventually consider, no, as negatively charged, no? So between two materials, no? The one that receives the additional electron, no? The one that gives off the electron, since equal sila at the very beginning, no? So kung magkulang ng electron, ti mahimo siya nga positively charged ang material, no? So again, no, materials that loses electrons, no? So ang positively charged material, positive charge, no, is a result of losing, no, electrons, no? So ang negative charge naman, no, results when a material, no, gains electrons, no, or electrons, no? So when there's an additional electron that is added, then the materials become negatively charged, no? Okay, so either the word is loses or it gives off, no? So no, it will result into a positively charged object, no? So before, no, the one that they are using, no, is to create, no, these charges. They have rubber rod, no. So if you have a rubber rod, no, so rubber is also another insulating material. If you rub it with fur, no, the skin, no, the dried skin of an animal, no, still with the hair there, that's called a fur. When you rub them together, you will, no, gain, no, negative charges, no. So The rubber rod probably will become no, negatively charged. No? A glass rod no, rubbed with silk no, is the one that develops the positive charges. No? So again, no, the combination of a glass rod. No? So this is way back no, in the olden days. No? So a negative charge is created no, by again no, by rubbing a rubber rod no, with fur. No? A glass rod, a glass no, rubbed with silk no, creates a positive charge. No? But however, today or this time around, no, they simply use plastics. No? Modern plastics can create both positive and negative charges. No? So, so what plastics are this? No? So a gray plastic called polythene no, can obtain a negative charge no, when you rub it with a cloth duster. No? So the one that you probably know remove the dust on. No? So cloth duster. If you rub that with polythene, no, a kind of plastic, you will get your negative, no? You will get your yes negative charge. When cellulose acetate, no, cellulose acetate strip. I think an acetate is the one that they ang acetate, no. So that's commonly used before, no, in some projector screens. So when you have that cellulose acetate strip, a clear plastic, guys, no, when you rub it with, again, on that same cloth duster, it will become positive charge. So both plastics today no, can create either a positive or a negative charge. No? While way back, no, you really have to find a glass rod, glass and no, a rubber rod no, to produce these things. No? I think the present day plastics, no, we call them as elastomer. No? So elastomers are industrial versions of different versions of plastics. No? Okay, so we have, so here is our electric charge. No? So when you rub, again, when electrons run away, no? When electrons move out, no? Then you will be left with a material that has more protons than electrons. No? So when materials have more protons, they become positively charged. No? Now, when the electrons in one material transfers to the other material, no, then this other material will have more electrons now than its protons. So therefore, it will become negatively charged. No? Now, what they observe is that when two no charges of different no nature, no, so if one is a positive charge and the other one is a negative charge, they have some kind of an attraction. No? When on the other hand, no, when they are both positive, no, so they have the same sign of charge, then they also act differently. No? So what do you think happens here no, in this left diagram? No? Attraction or repulsion? So they are both positive charges. So they will move no, away from each other. No? So they will push each other away. So what you have here is known as repulsion. No? So they will repel each other. On this other diagram, then what you have is attraction of two objects. No? So they attract, no? And then therefore they will move towards each other. No? Okay, now going into still no, in electric charge. So we formulated eventually the basic law of electrostatics no, that says like charges, no? So if they are both positive, they will repel no, or they will undergo repulsion. No? However, when they are unlike charges, no, one is positive and the other one is negative, then what we will see is attraction. No? So they are going to be attracted to each other. No? Now our electron theory, now which we already mentioned earlier, no? Atoms are made up of protons and electrons, and protons and electrons are equal in number, no, if the atom is neutral. No? However, if the atom is now charged, no, then the number of protons and electrons will no longer be equal. No? So protons are fixed in the nucleus, while electrons are the ones that are continuously moving around our atom. No? Now, when two objects again are rubbed together, the electrons now are the ones that transfers from one substance to the other, and therefore no creating the positive or the negative charges. No? Now, devices that detects no electric charge, we have no the electroscope, no, and the other one is known as the neon lamp. No, so they are there not to detect charges. No, but the famous one or the more common and less expensive one, no, the device is probably no the electroscope. No, and an electroscope, no, in a leaf electroscope, there are two pieces of either aluminum leaves, no, or ang iniya, no, there's a metal, and this small, tiny, no, uh, line like this on the side. This is actually a kind of a piece of aluminum foil. No? Kita ka ba sa aluminum foil? If you try to cut an aluminum foil, no? So if this is a piece of paper, guys, no? It's very thin, di ba? So if I'm going to slice a portion of that, and I'm going to put two of this, no? So kung duwa sila kabilog, like this one, no? I'll separate them, no? I'll spread them apart. Then now I have one leaf on the other side and another leaf on the other side. No? So when they are side by side, no, and if there's no force that exists between them, actually, no, they will just close like that. No? So these are an example of a leaf. No? So if you have aluminum leaf or aluminum leaves, no, the plural for leaf, then they can be placed in a flask, and the flask, no, can be called as an electroscope. No? So if they are sealed inside the electroscope, no, so there's an Erlenmeyer flask that sometimes no resembles this electroscope. No? So what happens with these leaves, no, or this metal with this leaf? No? So the side here is known as the uh, aluminum leaf. No? Now, very different from the aluminum foil. The aluminum foil sometimes medyo tig-ana sa yan, no? The aluminum leaf in our electroscope are so thin and then they are so movable, no? Or nagakuan, dali sila mag-swing. Now, others would also have no this gold leaf, no? And the gold leaf is also doing the same thing, no? But ang gold leaf naman niya very soft, no? So, how does the electroscope work, no? So when we put for example, you see this one, the diagram in the middle, so diagram B. No? So if initially now the electroscope has no charges there, and we bring this plastic, no, so this one, no, probably that figure here or this object here, no, is the charged plastic or the charged amber, no. Now if you put it near the electroscope, no, some of these charges now will begin to be transferred into the electroscope. No? So either we force the charge into the electroscope, no, and sometimes now we will now get another way of charging as charging by induction. No? So in this case, there's no rubbing of anything, no, except that this initial material, probably, no, the one that is pointed in red, is the one that was rubbed initially. No? So you'll notice that our object there, no, will behave, no, like a charged material, even though we did not rub the electroscope. No? Now what happened here is that we induced or we forced the charge into the other material. No? So without rubbing this next material, you can electrify or you can charge it, no, by introducing charges to it. No? And therefore, the process is known as charging by induction. No? Now, another way to to detect, no. So once the electroscope detects the charge, guys, no, the leaves will now diverge. No. So in the case of the electroscope, no, how do we know that there's charges that are present? No. So there's the divergence, no, of the leaves. No. So ginatawag na siya nga dahon kay literally it's like literally a leaf. No. So when the leaves spread out, no, so kung primero, tadlong ko siya, no? But once charges are introduced, you notice that the leaf now moves away, no? It moves away, no? And what do you think is the reason why this one diverge or moves away? Because they are both negative, no? So if they are both negative, and again, no, that's because of the transfer of the charges from this material, then we will see, no, that the leaves will diverge, no? Now that one will close, no, when the charge are eventually removed. No? But once the charge are still there, no? As long as the charge are still there, this one will keep on diverging. No? So the spreading or the diverging of the leaves, no, is an indication of an electric charge, no? The presence of electric charges. No? Now there are other versions of this electroscope. No? So this is known as the leaf electroscope, but there are also electroscopes that are cheaper in versions, and they call it as the pitball, no? Electroscopes. So these are the cheaper way of uh, creating an electroscope. So from here, we will see that there's literally a force, no? From the diverging of the leaves, there is a force here that pushes this leaf away from this metal, no? This metal column. No? So in the presence of a charge, there must be a kind of a force that is now created. No? Now for this NE or neon lamp, no? So it may have also, no, a similar behavior. No? But in this case, the neon lamp, no, is the one that now lights up, no? Because of the presence of the charge in the electroscope. No? So electric charges, no? Um, if you touch the metal, no, metal cup, no, of the electroscope, you'll notice that the leaves here will somehow, no, close. No? So in the first diagram on the left side, the leaf is diverging. But if when you put your finger on the metal cup, no, the leaves here will suddenly close. No? Why? Why will the leaf now starts to go back, no, and close? No? When still, no, this introduced charge, no, is still present. No? Wala pa manigin kuha ang charge that the charge material that is causing the divergence. No? But somehow, no, by the touching of the hand, what happens, no, is that your hand, no, acted like a ground, no, a ground or grounding principle. No? So a ground, guys, no, is resembling the touch, no, of the finger. No? So what's the meaning of ground? No? So when the hand, no, touches the electroscope, the charges now transfers to the hand. No? So since the negative charge transfers to the hand, then the leaf starts to close back, no, to its original shape. No? Now, the principle of grounding, no, is that we believe the ground, no, that we are putting our feet on is the place where electrons always go, no, or electric charges go. No? So in some of our refrigerators, no, in some of our devices, no, at home, no, TV or other electrical device, ref, washing machine, no, we always put a wire there, no, that always goes to the ground, no. We attach a wire and we place it going to the ground, no. Now the reason for that, no, is that, no, similar to this, no, there would be no electrostatic charges that will remain in your ref, no. So if you want to avoid electric shock, then you have to connect that grounding wire, no. If that grounding wire is not properly connected, sometimes when you hold suddenly, your refrigerator, you will get that sudden jolt, no. Ma makibot ka bala nga dumay nangagat sa kamot mo, no. So we call that as electrostatic charges, no. Now these electrostatic charges on some applications, they also appear to be very, very critical, no. There are some applications of that, no, that makes them, no, so crucial and very damaging also, no. Like I think, no, in the earlier space exploration sa mga movies about movies about the first time na they go to the moon, no, like the Apollo project, no, of the US. You'll notice that the shoes that they are wearing, no, may ara na silang ginataklob da nga plastic, no, as they walk from the building where they come from, no, into the rocket that they will ride on, no. They will only remove that plastic on their foot once they already, reach the rocket, no. So they will remove that, no, and again, no, to avoid the accumulation of electric charges on their feet, no, or on the soles of their shoes, no. So the soles of your shoes are made of rubber, and when you rub it on the ground, guys, no, or on the floor, it will uh, it will allow, no, electrons to transfer to that shoes, no. Now if the onboard computer of a rocket, no, is so critical, no, and can easily be damaged by this electrostatic charge, to avoid that, no, they have to shield their shoes, no, with a different cloth, no, that will not attract electrons, no. So their shoes therefore will not, no, be electrified, no. So that is to avoid damaging the onboard computer or creating a spark, no. This spark sometimes, no, creates an explosion, no, in the earlier ang mga una nga mga versions sa mga Apollo rockets, no. There were several cases of fire, no, that burns, no, and kills astronauts, no, because of this electrostatic charge, no? So that's how critical are electrostatic charges as well, no? I hope you have no questions. So